Welcome back to your free training course for Windows 7. In this video, I will look at caching options that Windows uses for fixed hard disks and removable devices. I'll then look at removable device policy. Removable device policy allows you to quickly configure security for removable devices on your system. Lastly, I will look at the disk checking tool included with Windows 7, simply called Check Disk. Without further ado, I will change to my Windows 7 computer. First of all, I want to look at the caching options on my local hard disk. To do this, open Windows Explorer and then select the Properties for one of the hard disks. From Drive Properties, select the Hardware tab. From here, you can see all the device drivers for all the disk drives in the system, not only the ones for the hard disk. To access the caching settings for the hard disk, select the properties for the hard disk and then select the option Change Settings. From here, select the tab Policies. Notice that Enable Write Caching on the device is enabled by default. If the device has an onboard cache, which it should, Windows will use this cache to speed up writing to the hard disk. The risk with having this option enabled is that if power is lost to the system, then any data in the cache will be lost. Remember that any data in the cache has not been written to the hard disk. This may sound dangerous having this on by default, but the thing to remember is that the NTFS file system, which Windows 7 uses by default, is a transaction-based file system. What this means is that before a write is written to the hard disk, a transaction is written to a log stating what is about to happen. If power is lost before the write is complete, Windows will pick this up and check the drive for errors. Having said this, any data in the cache will be lost. Windows in most cases will be able to fix the file system, preventing data corruption and damage to the file system. NTFS is a lot more robust than the older file systems such as FAT, but I would still shut your system down correctly. Don't just pull out the power cord. If I right-click on my taskbar and select Start Task Manager, you will notice that under Physical Memory there is a figure for cached. This is how much memory the computer is currently using for the cache. The cache is dynamic, meaning that it will automatically get bigger and smaller as required. Under this is a figure called Available. This is how much RAM is available for programs at any one time. At the bottom, there's a figure called Free. This is a very small percent. This is how much RAM is not being used. Looking at only the free figure, it would appear that no RAM is left and programs need to be closed, or more RAM purchased and installed. What happens is that Windows will use the entire spare RAM for cache when it is not being used for anything else. When a program requires more RAM, it will make the cache smaller and give more RAM to the program. You can now understand why, when you run more programs, there is less RAM for cache. Even though you may have enough RAM for all your programs, the cache size gets smaller, and this can affect performance. If I now change back to my Windows 7 computer, I will cancel out of the cache settings for the hard disk. I will now select the device driver for my USB thumb drive. Once again, select Properties, Change Settings, and then select the Policies tab. The settings for USB devices, like thumb drives, are different from hard disks. The default is Quick Removal. This setting disables write cache on the device. If you have ever opened a document on a flash drive and saved it, you may have noticed a couple of seconds pause while the application saved the file. When you do not have write cache enabled, the application must wait for the write to be completed to the USB thumb drive. The second option, Better Performance, will enable write cache to the USB thumb drive. When this is enabled and data is saved to the USB flash drive from an application, the file will appear to save straight away, returning control back to the application. The reality is that behind the scenes, Windows is transferring the data from the cache to the USB thumb drive. This is where the problem comes in. If you have it set to better performance, and you save a file to the USB thumb drive, and then pull the USB thumb drive out of the computer, what happens is that the file has not finished being transferred from the cache to the USB device. In order to ensure that all writes are completed correctly, you should manually eject the USB device. When the USB device is ejected from Windows, Windows will ensure that all writes are completed on the device before telling you the device can be removed. The reason that Microsoft has quick removal on by default is that most people will remove the device from the system when they think the application has finished using it. Most people don't use the manual eject option, and thus having the option set on better performance increases the risk the average user will remove the device before Windows is finished with it and thus lose data. If I now select the Details tab for this device driver and then select Hardware IDs, these are the hardware IDs that Plug and Play uses to identify the device. Here you can see the ID USB storage for Kingston disks. If I want to select all Kingston USB drives, I could use this hardware ID. If I wanted to be more generic, I could select the option USB storage and the generic disk option. However, this option may also select USB-based hard disks. If you wanted to block or allow certain devices on the system from being used, make sure you select the correct hardware IDs. Dealing with hardware IDs like these can be a little complex. Thankfully, Microsoft has added some settings in Windows 7 so you don't have to work with the hardware IDs to limit or allow access to removable storage. If I want to block any storage device without having to worry about hardware IDs, I can instead open Group Policy from the Start menu and navigate down to the following: Computer Configuration, Administrative Templates, System, and then Removable Storage Access. In here, you can block many storage devices, not just the removable ones. Most of them will have the option to deny execute, read, and write access. From here, you can block optic drives, floppy drives, any type of removable disks, tape drives, and WPD devices or Windows Portable devices. WPD devices include devices such as smartphones, digital cameras, and portable media players. There are a lot of options in here. To make it easier, Microsoft gives you the option to simply deny access to all removable storage devices via one setting. One interesting setting that Microsoft gives you below this is allow all removable storage devices to be available when the user is accessing the computer via a remote desktop. All these settings will not take effect until you reboot the computer. At the top, you have the option to force a reboot after so many seconds. This prevents the user staying logged in permanently, meaning the changes will never take effect. This covers all the removable device policies. The next thing that I want to cover is how to check a hard disk for errors. If I close Group Policy and go back to the properties on my C drive, the tab I want to select is Tools. Notice the option at the top, Check Now. When I select this, I get two options. By default, Windows will automatically fix any file system errors that it finds. The second option will scan all the sectors on the hard disk to make sure that all sectors are usable. This process does take a long time to complete, and I would not worry about performing this step on hard disks that are working well. If you do believe there is a problem with your hard disk, you are best to perform this step. Hard disks with bad sectors are generally an indication that something is wrong with the hard disk and it is starting to fail. When this occurs, it is best to replace the drive quickly. Disk check can also be run from the command line. To do this, I will open a command prompt from the Start menu, making sure that I open it with administrator privileges. If I run the command CHKDSK from the command prompt with no switches, this will start CheckDisk. Notice that CheckDisk will run in read-only mode. If it finds any problems, it will not attempt to fix them. I will cancel CheckDisk by pressing Ctrl+C, and then run it again, this time using the /F switch. The /F switch will fix any errors that it finds. Notice that when I run it, I get a message saying that the drive is locked. This means that there are open files that CheckDisk cannot check. This is to be expected since the Windows operating system is on this hard disk. CheckDisk will now ask if I want to schedule the disk check next time the computer starts up. This will ensure that no files are open. If I were to run CheckDisk from the GUI interface, I would have got a similar message. In this case, I will press No. If you want to check for bad sectors, you can run CheckDisk with the /R switch. Once again, I will be asked if I want to check the hard disk when the computer starts up. This time, I will select Yes. To restart the computer, I will run the command shutdown with the /R switch for reboot and the /T switch with 0 for reboot right now. Once Windows 7 has rebooted and is starting up, I will get a message telling me that a disk check has been scheduled. Windows will give you 10 seconds to press a key to cancel the disk check. You may have seen this message before. If Windows crashes and Windows thinks it is wise to check the hard disk, Windows will automatically perform a disk check when the computer starts up. That's it for this video. In the next video, I will start looking at the Event Viewer. The Event Viewer is an important tool to understand in the troubleshooting process. I hope you've enjoyed this video. Thanks for watching.